Hello everyone, this is Nilesh Gule here once again. In the last session, we discussed about the user-defined types, that is structure and enum. In this class, we will discuss about the functions in C# and arrays in C#. Let us get started with the functions first. What is function? Function is basically the set of instructions, block of instructions, which can be called again and again. So it is reusable block of instruction. For a function, you can give certain inputs. It is called as arguments to the function. And then you can expect some result from the function. You call it as the return value. I will give you a real life example. If you want to make some furniture at your house, all you do is go to the carpenter, give him some design, some requirement and money. The carpenter process your request and prepare a furniture, returns back to you. After a few days, if you have a requirement for another furniture, you can call the carpenter once again with the different requirements, with the different design, and then he will return you another new furniture. So the carpenter over here is like a reusable function, which you can call again and again for doing the different things with the different parameters. Of course, when I talk about carpenter, the carpenter may take different arguments, but it is specialized in making furniture only. So every function has got a specialty that it is doing a certain task. Now, when you write the function in C#, here is a basic syntax. In this case, we have written one add function. This add function has got return value integer and it is having two parameters a and b. Internally, it is doing addition of two numbers and returning c. While calling the function, all we do is use the name of the function and we pass the arguments to the function. These arguments are collected into the parameters a and b, and then the result is calculated, which is written back and collected back in the called function. Now, there is one technical detail. Note that the variables which are declared inside the function definition to collect the values, to collect the input, they are called as the parameters. While the actual values passed to the function, they are called as arguments. Now that you know these basic concepts for any function, we can go ahead and discuss some concepts related to the functions in C#. The very first thing I want to talk about is positional and named arguments. By default, the function arguments are positional argument, meaning by the first argument is collected into the first parameter, second argument is collected into the second parameter. And this is similar concept into the other languages like C, C++, and Java. So argument are matched to the parameter by their position. However, this may not be suitable when my function is taking many arguments. If function is having 10, 12 arguments, at that time, it is very difficult to track the actual usage of the function. It is very difficult to understand the actual call of the function just looking at the parameter sequence. In order to make it more readable, we can associate the function argument with their parameter names, and we can understand what values are actually passed. Also, when we associate the name, it is called the named arguments, and in that particular case, you need not to pass all the arguments in exactly same sequence. They can be passed in arbitrary order. Let us take an example of this. Let me open the Visual Studio and Then I will open our old application, that is basic solution. And into this basic solution, we can create a new C# project. It will be again a console application, and this console application, I call it as functions. Over here, I will declare one very basic level function, let's say print info. For time being, I'm making these functions as static function so that I can call them directly without creating the object of it. We will discuss about the static in detail in a separate session. So right now it is static, and let's say the name of the function is print info 1. Inside this, I want to pass certain values. Maybe I want to pass name of the person. Maybe I want to pass the age of a person. I can pass, let's say, email of the person, and I can pass the address of the function. So there are total 4 arguments I'm trying to pass. Now, what this function is doing? This function is only printing the arguments. Let me show you another new way of printing these arguments, and that can be done by using something called as a templated strings. The templated string where you can display the value that you want to display inside a curly bracket. So this name is directly accessed over here, and on the similar way I can say age is accessed over here, and you can have, let's say, address is equal to address, and then email is equal to email. You may refer it as a template string, or it is more popularly known as something called as a string interpolation. Now, how will you call this function? Now there are two ways. You can call by positional, or you can call by the named argument. Let me call function with positional arguments. And in this particular case, I can call print info. The first argument, that is name, I need to pass, let's say, James Bond. And then the second argument is age, I'm passing over here. The third one that I'm passing is address, let's say London. And fourth one, maybe I want to pass some email there. That's it. In this particular case, the first argument is collected in the first parameter, the second one collected in the second parameter, the third one collected in third parameter, fourth one collected in fourth parameter. That is the reason this is known as positional arguments. However, then we have one more. We can now also go for the named arguments. So I can call the function with named arguments, where I want to pass the 4 arguments. You might pass, let's say, age is equal to something like this. You might pass name is equal to something like this. You might want to pass some address is equal to, and you may pass the email is equal to like this. I hope that is wonderful. In this particular case, if you are seeing it very clearly, there is absolutely no need that argument must be passed in order, because these arguments will be matched by their names. They are not going to be matched by their position. And we can run this and we can cross check it. Let me mark this project as startup project and Control F5 to run this. I hope you are able to see that the name, age, address, email, everything is passed correctly. Then people have next question. Is it also possible that I can pass certain argument as positional and certain arguments as a named argument? Yes, we can call the function with mixed arguments. Let us see one example. Let's say I can pass, let's say print info. Maybe I want to pass the named argument. Let's say name is equal to something. Then I want to pass the age. Let's say I'm passing the age over here. Then maybe I want to pass the email. Let's say this is the email over here. And then I have something, let's say address passed over here. If you've seen the few arguments over here, these are positional, while the other arguments are named arguments. Is it allowed to be passed? Answer is yes. This will work very well, provided the positional arguments are passed on the appropriate positions. Now, since the age over here is 45, it has to be passed as a second argument because we are not giving name for it. What will happen if you try to mix it up? Like for example, instead of passing 45 as a second argument, if I try to pass maybe 45 as a third argument, will this work? Answer is no. This will give me the error. Why this is giving me the error? Because in this particular case, the positional argument, unnamed arguments, they are not given as per their accurate syntax, accurate position. So the error, the positional arguments must be given on right position. That's it. So as long as the argument position is correct, you can deal with positional parameters over here. Now that you have understood the basic concept of named argument and positional argument, we can go on to the next concept. And this next concept over here I want to talk about is optional arguments. So while defining a function, default values can be assigned to some of the parameters. And if default values are already given, then while calling the function, passing those parameters is not compulsory. Here is a simple example where the add function is taking two compulsory parameters a and b, while c and d have given the default value 0, 0. So passing c and d while calling the function is optional. If I'm passing the value of c and d, they will be collected and they will be used. And if we are not passing, the default value passed over there 0, 0 will be considered. So you see that in first call, the add is passed with 22 and 7. So 22 and 7 will be collected into a and b, and c, d, which are not passed, will be considered 0, 0. In the second call, the a will get 22, b will get 7, c will get 3 as we have passed it, and as we are not passing d, d will get 0. And the next one, the another call to the add where we have passed all four values. So a will be 22, b will be 7, c will be 3, and d will be 14. In this particular case, no argument is taken default. Please note that the optional argument or default argument is a compiler level feature. Whenever argument is not passed, by default, the given default value is used in the IL code for that function call. It is directly replaced. And please note, very, very important thing, you cannot make certain in-between parameter with the default value or as optional parameter. All optional parameter in the function definition must be given after all required parameter. That is the reason first we have written the required parameter a and b, and then we have kept the optional parameter c and d. If you want, you can keep all four parameters as optional. That is absolutely allowed. Let us take some example of the optional parameter now. So again, I'm going back to this. Let me kind of skip this main and I will write the next print info function. Now in this print info function, I'm mentioning print info 2. This function is doing almost similar job. However, I will say address is equal to maybe anywhere. And email, again, I have to give some value. Let's say that it is unknown. Great. Now I want to write the main and I want to call this print info 2, where I can pass the first argument, let's say James Bond. The second argument, I want to pass age. The third argument I want to pass is address. And fourth argument I want to pass is email. Since I have passed all four arguments, all those four arguments will be used directly. However, what if I pass one less argument? Let's say I'm calling print info once again, where I'm passing Superman. Maybe I'm passing some age. I'm passing the address, but I'm not passing the email. In this case, you can check that the email will be taken the default value which was given unknown. And then we can continue. Let's say one more print info where I'm just passing, let's say Spider-Man, and maybe I'm passing some age. I'm neither passing address nor passing email. In this case, the address will be automatically picked up as anywhere and email will be picked up as unknown, which you can see it over here. Of course, you may continue to use the named argument along with this optional argument concept. Means you can specify, let's say age is equal to something and name is equal to something. And when you have used name argument, the sequence is not compulsory. That's wonderful. Now you have understood this concept called as optional arguments. Now it's time to go ahead with the next concept. The question is, can I write a particular function inside another function? Let's say this print info function, can I directly write such kind of print info function inside this? Is it allowed? Answer is yes. You can write a function inside another function, and such kind of function is called as a local function. The local function can encapsulate some business logic which you do not want to make it available, you do not want to make it accessible outside this main. The scope of this print info is inside main only. And then of course you can call this print info over here once again with certain arguments as per your requirement. Let me run this and you can check the actual execution. So let me run it. It's good. If you want, you can try to debug this by using F10. Please note that the function is defined over there, but in this particular case, function is not called. So it has just skipped that as an execution and jump to the first executable line in my main function, which is nothing but a function call. And then I press F11, which is showing me that it is now executing the function line by line and then producing the desired output. I hope you understood this concept. There is one interesting thing about the local function. These local functions can access the local variables of the outer function or enclosing function. Here print info 1 function is enclosed in the main function. So if I'm having some variable over here, let's say greet hello, then what will happen? You can access this greet inside the print info function. How? You can directly access it like this. Maybe I'm using the variable greet directly and the value hello will be printed inside this. I hope that is interesting. And for your information, it is not necessary that you are only able to access it, but eventually you will be able to modify that also. Means what I can do is, let's say grid is equal to grid dot kind of uppercase. What I'm doing is converting this hello in the uppercase. Do you see that? Yes, hello is done in uppercase. Please note that the changes are now permanent inside this variable. Meaning by, if you try to access that particular variable into the main, let's say grid is equal to, and I want to print the grid over here, it will actually show you the modified, the capitalized hello. Do you see that? This particular feature is allowed in C#. However, this sometimes might be unexpected. You may not be really interested in accessing the variables from the outer method, and this access might have done maybe by mistaken, and since the modifications are done, you might see some absurd results later. So is there any way that I can avoid these accidental mistakes? Yes, you can do that. What you can do is that you can make the function as static local functions. Like this, I can make the function as static local. If my function is static local function, the static local function cannot access the variables from the outer method. If you try to access, it will give me error. A static local function cannot contain a reference to the grid, right? So if you want to make some method which is self-contained, which is having all its required variables either inside the function or as its parameters, then it is good idea that you declare that particular function as a static local function. So static local function, you cannot access the local variables of the outer method. Cannot access local variables of outer or enclosing method. That's it. This is one of the interesting concept called as a local function. This concept is not really available into the C, C++ or Java, but you might see it available in the other programming languages like Python or JavaScript. Now that you have understood about the local function also, let us move on to the another important and interesting concept. How we can pass arguments to the function. Now, C# is quite rich in passing arguments to the function. There are so many ways I can pass the argument to the function. I might pass the argument by value or by reference. You can have a concept called the ref keyword. We have like out keyword. We also have in keyword. There's also something called the params keyword. There are so many different ways that we can deal with. Let us take with some example. Let me write one classic function, that is to swap two numbers. Let me ignore this main and let me write a function. Let's say I want to make it public static void swap one function, where I want to pass x and then I want to pass y. How we can do this swapping? I guess this swapping can be done very easily by saying t is equal to x, then x is equal to y, and then y is equal to t. Hardly 3 lines is enough for interchanging the contents of x and y. If you want to print the result, let me print the result inside swap one, where I want to show x is equal to x and y is equal to y. Good. Now, let us call it from the main and see if it is printing the expected result. Let me check num1 is equal to something, num2 is equal to something, and I'm calling swap1, where I'm passing this num1 and num2. Let me print the values before and after the function call. So let me print it over here where I can say that this is before swap and this is num1, num2, and then we have after swap again we can have num1 and num2. Well, now we can run this. Now you can see that the values that we have in a main num1 and num2, inside swap 1 you see x and y, they are interchanged like 7 and 22, but after getting back to the main you still see the old things. Do you know why it is so? Answer is very simple, because in this particular case whatever values that we are passing, these are values pass by value, and whenever there is a pass by value, the copy of the arguments is created into the parameters. Let me explain you with some example. Let's say if we have this num1 which is 22, and then we have num2 which is 7 in main. So before function is called, num1 is 22 and num2 is 7. But when I'm calling the swap function, inside swap function, the local parameters x and y are created, and x will collect the value 22, y will collect the value 7. That's great. And then we also have one temporary variable. The logic that we have written for swapping is something like this. T is equal to x. So initially the t will be 22. X is equal to y. So the x value which was earlier 22, it will be now replaced by, let's say, 7. Done? And then you can see y is equal to t. That is, y will be then replaced by 22. Correct? So you see that x and y, they are now interchange. That is good. Where you see this into the output as well. The x was 7 and y was 22. Please note that all the changes are done into the local variables of the swap1 function. But after function is completed and it return back to the main, you will find that these local variables of the swap1, they are literally destroyed. And then you see that we are printing num1 and num2 again 22 and 7 as it is, because they are nowhere affected by the function call. Why all these things happen? Because num1 and num2 both are value types, and whenever we are passing these value types to the function, their copy is created into the parameters. Whatever function is doing the changes, all the changes are done in that copy, and that is the reason those changes are not visible again in the calling function main. Now that you have understood that this is going to happen, do you know any solution for this? Let me tell you, there are two solutions for this. The solution number one, where I say that the value types are always passed by value. Then instead of using value type, can you go for reference type? Because whenever you are passing a reference type as an argument to the function, reference type, that is typically the objects of the classes, they are always passed by reference. So you are only sending the address, and through that address you can actually do the changes in the original object. Let me show you the example over here. The way we have written, let's say, swap1 function, we can go ahead and we can write, let's say, swap2 function, which is doing the swapping of two reference type. But for that sake, why not to declare one class, a simple reference type? which is actually holding the number, let's say integer n. And one constructor that I just want to give right now is n is equal to 0, and then I can write it this dot n is equal to n. That is good. Now, how do you swap these two my int? Let me write public static void, and we have another swap function, let's say swap2. Now, instead of taking int, I want to take my int as an argument over here. And this my int over here, these are references. These are addresses. These are not the actual values. So we can write the logic of swapping by saying x dot number is equal to y dot number, and then y dot number is equal to t. We can print the data inside the function in the similar way, where I can mention swap2 and I'm printing x dot n, and then I can mention y dot n. I guess that should be fine. Now, if you have understood this, let us go ahead and use the main method. Now, inside main method, I want to call this swap2 function. How I can do this? Let me go ahead and declare, let's say my int, let's say num1 is equal to new my int, and I'm passing the value 22. Let's say we have num2, it is equal to new my int, and I'm having value 7. We want to print before swap and after swap. How we can do that? Let me use console.writeLine saying this is before swap, and I can mention num1 is equal to num1.n, num2 is equal to num2.n. Similar thing I can do after the swap as well. But how exactly I'm going to call this swap2? I can call swap2 just by passing num1 and num2. Let me first run it. You see the output, and in the output you will see that this num1 and num2, earlier it was 22 and 7, but now it is 7 and 22. Why it worked in this situation? Answer is very simple. Because in this particular case, my num1 and num2, these are reference types. And as I said that whenever reference types are passed to the functions, they are always passed by reference. So we are not sending copy of num1 and num2. Rather, we are sending the address of num1 and num2. Again, we can go ahead and we can draw the diagram for the same. Let's say that we have num1 over here. This num1 is, let's say, address 1000, and it will store the actual data, let's say 22, inside the object. So inside the object located at the address 1000, this is a object of my int type, and this 1000, it is pointing to this my int object. Let us draw something similar for num2 as well. So num2, let's say, is address 2000, and 7 is stored, the value of n, inside my int object located at the address 2000. So num2 is a reference type which is pointing to this object as well. That is good. And then you have the next question. What is happening when we are calling swap2 function? Is it creating x and y? Answer is yes, it is creating x and y. But this x is reference type. So it is not storing that 22, rather it is only keeping that address 1000. And it is now pointing to the same object on the heap which was created in the main. Likewise, we also have y, which is storing, let's say 2000, which is pointing to the num2 object which was created on the heap in the main. And t is an integer. T being an integer, it is a local variable created over here. Now, exactly what will happen on this line? T is equal to x dot n. So x is referring to the n value, let's say 22. So this 22 will come over here. Then x dot n is equal to y dot n. Y dot n is nothing but 7, and you will find that this 22 will be replaced by 7. That is good. And then y dot n is equal to t. This y dot n, earlier it was 7, it will be then now replaced by t value, that is 22. Yes, the swapping is done in this particular case. And when we print the result inside the function, you see exactly same result, that x is equal to 7 and y is equal to 22. But once your function is finished and then you return back to this, now you can check that num1 and num2 are still pointing to the same object, but the content inside the object, the state of that object is modified from 22.7 to 7.22. And that is the reason the changes done inside the function are visible in the calling function. This is nothing but pass by reference. So the moral of the story is, whenever we are passing value types to the function, their copy is created, and any changes done inside that particular function in that particular primitive values or value types will not be reflected back in the calling function. While whenever we are passing reference type as an argument to the function, any changes done inside the function in that reference type in those objects will be visible, will be reflected in the calling function, because those functions, the called functions, are actually doing changes in the original object. They are not only modifying a copy, right? Now you have understood this basic concept. Just for your information, this concept resembles very well to the Java's pass by value and pass by reference. But now C# has got something special. Now, what is new and special feature of C#? To explain you the new and special feature of the C#, I want to show you a ref keyword. Using ref keyword, you can directly modify the variables inside the function, inside the called function. And this is applicable for the value types as well. Means, let me again write our old swap1 function. Let us call it a swap3 function. And in this particular case, I want to say that this x and y should not be treated as pass by value. They should be treated as pass by reference. That can be done by using the ref keyword. Now, whatever changes we are doing in x and y, these are considered as actual changes done in the past arguments, where we are passing the arguments from the main function. Let me call this. I guess something similar code we had written earlier. So let me do the similar job once again. But while passing these the arguments to the function, where these are the ref parameter, I have to use ref keyword while passing the arguments as well. Now you can see that if I run this, you will see that the changes are done in the function, and those changes are reflected back in the calling function as well. And this is nothing but magic of the ref keyword. Using ref keyword, we can pass certain values to the function, and we can modify those values inside the function. So typically, people use the ref keyword to represent something called as a in-out parameter. The parameters which are giving input to the function, and in the same parameter, you are getting some output from the function. Here we are sending some value into the x, but then we are getting back the modified value from that function, let's say y. Remember the basic rule of the ref keyword. The ref arguments must be initialized before passing to the function. And inside the function, you may modify it or you may not modify it as per your choice. But yes, many times people pass the ref keyword because they want to modify it. Now, let me show you another type of parameter to the function. And this time, there is a concept called the out parameter. The concept of the out parameter is we want to use the parameter not to give the argument to the function, to give the input to the function, but I want to use it to get the output from the function. How we can do that? Let me give a try. Let me write one very basic, very classic kind of function. Let's say I want to do division of two numbers. What's the typical way we write the division of two numbers? Let's say I want to divide. Let's say the result could be double, but then we have method divide. And if I'm passing one numerator and another denominator. Good. The simplest answer could be numerator divided by denominator. But you know that this could be a problematic job if the denominator is 0 and it may fail at runtime. So what could be the elegant way of writing a divide function which is not throwing any kind of exception? At that time, I might consider using a boolean, and we can return true if the division is successful. But in case if denominator is equal to 0, in that case the division is not possible, we can indicate the return false. But the question is, how do I then return the result of the computation? True and false will only show me the status. How I will give the actual division result? And this is a situation where I can use the out parameter. So out double res. The res is the out parameter, and this out parameter must be initialized inside the function before returning from the function. You can check that since I'm returning false directly without doing any modification or any initialization to res, it is giving me the error. So for time being, I can make res is equal to 0 as some default value. If denominator is equal to 0, then I can say return false. At that time, the res value will be 0, but returning false is an indication that division is not possible. If division is possible, then we will do the actual division and the result will be collected into the res, and then I will return true to indicate that we have done division successfully. Well, how you are going to call it from the main? Let me declare the variables over here. Num1 is equal to something, num2 is equal to something. You may want to take these values from the end user using console.readline, and then I want the result to be collected. I can call divide, I can pass num1, I can pass num2, and I want to collect the result in that result. So I will use the out keyword with result. If the return value is true, which is indication that the result is successfully calculated, I will print the result. Like if divide has returned true value, let me print the result here. But otherwise, I can simply print the message that cannot divide by 0. That's it. Let us give a try. Let me run this full application, and you see that 22 divided by 7 is quite valid division, and the result is 3.14. However, in this particular case, if num2 is equal to 0, what will happen? At that time, res will be equal to 0, and since denominator is 0, the condition is true, it will return false from here. And since it is returning false from here, if block condition is not true, it will go to the else and it will print cannot divide by 0. I guess that is wonderful. This is how you can make effective use of the out. You must have understood in this particular case that whenever we are using out keyword, it must be initialized inside the function. And you need not to initialize it from the calling function. But you can compare it with the ref. Ref must be initialized in the calling function, and you may not modify it in the called function. Now you've seen that there is a ref keyword, there is an out keyword, and for that sake, there is also one in keyword. The in keyword is an indication that you are using it as an input to the function. So you may specify that this numerator and denominator, these are nothing but input. This will increase the readability of the code, and when we are passing certain parameters, it may not create the copy unnecessarily because we are just going to use it as an input parameter. So compiler can do certain optimization behind the scene. Well, we talked about 5 types of the parameters over here. One talks about how do we pass the arguments by value, or we can pass the arguments by reference. We talked about the ref keyword. We talked about the out keyword. And finally, I also talked about the in keyword. By the way, when we deal with the function arguments, there is one more keyword called the params keyword. But we can discuss about the params keyword only after we discuss about the arrays. Now, we had enough of discussion about C# functions. Let us go ahead and let us talk about something called as arrays in C#. Here you can see that in C#, like other programming languages, we can have 1D array and multidimensional arrays. Let us first get started with the basics, and then I will also tell you what is special in C#. Let us first begin that what exactly the array is. Array is collection of elements of the same type. So when I'm creating array of integer, all the elements inside the array must be integer. If I'm creating array of double, each and every element must be double. If I'm creating array of person, then each and every element must be person. I can create the array of value type as well as I can create the array of reference type. And if you recall, the array itself is a reference type. So well, how I can declare the array? There is the first example you can see over here. Int ARR. This sign represent that this is one array reference is equal to new int 5. So I'm trying to create the array of 5 integer. And these 5 integers are uninitialized. So default value of these 5 integers will be 0, 0. If it was array of double, then the default value would be 0.0. And if it is array of boolean, then uninitialized default boolean would be false. Then we have another example where I have created another array where we say new int 3 and 3 integers are given 11, 22 and 33. That can be done. And then there is one syntactic sugar, meaning by if you want to initialize the array directly, then writing this new expression is not required. So you can see the next example, int ARR and curly bracket 10, 20, 30, 40. Here I can see that it is an array of 4 integers. Now in this particular typical example, there is no need to write new int because we are doing initialization at the point of declaration. In this particular case, internally still, even though we have not given the new keyword, internally still the object of the array is created on the heap. Don't forget, array is a reference type. It is internally storing the length of the array. Maybe it is 4 and the actual values 10, 20, 30, 40 are stored. And then the address of that array will be stored as a local variable ARR on the stack. Let me go ahead and try to access it. And for that, I will create a new project. Let me name the project as arrays. And inside this, let me explain you the concept of 1D arrays. Now I'm declaring exactly same array. Let's say it is 10, 20, 30 and 40. All good. If you want to print the length of the array explicitly, so I can print the length of the array explicitly by using arr.length. And if you want to access a particular element of the array, you can print the array element as index. So I can give the index, let's say ARR of 0. The 0 index represent the first element, very first element of the array. So going back to the diagram, you can take a look at, in this diagram, I can have 10 at index 0, 20 at index 1, 30 at index 2, and 40 at index 3. So if my array is of 4 element, then the valid indices are 0, 1, 2, and 3. In general, the array elements can be accessed using index operator using valid indices, that is 0 to n minus 1. 0 to n minus 1. If you try to access any element beyond that array index, it will throw the exception at runtime. Let us take a look at, can we do it manually? Here I'm printing ARR 0 and then I can print ARR 1, ARR 2, ARR 3. Don't worry, they will print the expected result. And expected result we have is 10, then 20, then 30, then 40. There will be a trouble when I try to give it 4 or maybe minus 1, something like this. Now there is no such valid index over here, and that will cause the exception. Let us run the application and check which exception you are getting. I guess I should be making this as a startup project and then I should run this. And you see the exception, index out of range exception. Great. Now that you have understood it, but if my array is like really big array, are we going to print on the individual statement? No way. I can use a typical for loop over here. So I can use for loop for integer I is equal to 0, I is less than arr.length, I plus plus, we can access the elements one by one, and then console.writeLine. In general, I want to print, let's say arr of, let's say I is equal to maybe arr of I as a value. And you will see similar output once again using a loop over here. Now, if array is having 10 elements, the loop will repeat for 10 times and I will see all these values along with the index. But many times you may not be interested in the index of the element. All you are interested is just the array element. At that time, instead of using the for loop, you may go for something called as a for each loop. In this particular case, we have used a for loop, but we can use a for each loop. Please note the concept behind for each loop. The for each loop is repeated once for each element in the array. So I can go for each integer number in ARR. Then we can say console.writeLine and we can access the each element over here like this n. So this particular loop will be repeated in my case for 4 times. On the first iteration of this particular loop, the n will get the value 10 and the body is executed once. The second iteration of this particular loop, n will get the value 20. And in the third iteration of the loop, n will get the value 30. And in the fourth iteration of the loop, n will get 40. And in the next iteration of the loop, it realized that all elements in the array are finished. So loop is not going to be executed anymore. It will just come out of the loop. And if you have written any statement after the loop, that will get executed. By the way, this n variable is scoped only for the loop and is not accessible outside the loop. Let me show you quickly. If I'm running this, you are expecting that element 10, 20, 30, 40, they are printed individually. I believe you have understood how exactly the array works. So let us go back and try to understand that we can have array as a collection of elements of the same type. You may use the integer array, you may use a double array, you may use the Boolean array, and so on and so forth. If you want, you can also have array of reference type. Let me quickly take one example of array of reference types. I'm creating the 1D array only, but it is an array of reference type. So 1D array of reference type. And maybe I can create the string array where I'm saying that new string and 4. That's it. In this particular case, what will happen? In this particular case, this ARR will be some address. Again, let's consider 1000. And it will point to one array object. That array object will store the length is equal to 4. And then there will be 4 references in the array. 4 references, because string is not the value type. String is a reference type. So it will have the references, but currently no strings are initialized at all. So by default, all these 4 references will be null, 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 null. This is array of 4 references, and all these 4 references are null only. This is nothing but my array object altogether at location 1000. Later on, you may write it, let's say ARR of 0 is equal to, let's say, India. In this particular case, what will happen? India will be one of the object of string type. It might be at some location, for example, 100, and then that 100 address will be stored instead of null at 0th location, and it will point to this. On the similar line, you can continue. You can again write ARR of 1 is equal to, maybe I'm writing ARR of 1 is equal to Lanka. Now, what is happening? There is another string, maybe Lanka, created at some address, for example, 200. And this address 200 will be stored instead of null. Likewise, you can add the multiple strings over here, and their addresses you can store into those references. On the similar line, I can create the array of the person references or any other class. Please note that whenever we are creating the array of reference type, internally we are not storing the whole object. Internally, we are storing only the references. And by the time we are not initializing them, all those references will be null references. Let us complete this example quickly. So AR of 0 is equal to maybe India, maybe AR of 1 is equal to, let's say, Lanka, maybe AR of 2 is equal to, let's say, Nepal, maybe AR of 3 is equal to something, let's say, Bhutan. Good. And then how you are going to access these array elements? Again, you can either use for each loop or you can use the for loop with the index. Let me use for each loop, where I say that for each string, let's say country in ARR, we can print the country over here. Let me just run this. Great. But please note that whenever we are creating an array of string, each and every element must be string only. You cannot have one integer in between. This is not allowed. Now, what if I want to create the array of mixed type? Is it feasible? Usually you do not need this, but somehow, yes, it is feasible. So let me show you how you can create the array of mixed type. And that is typically done by using the array of object type. So I can create the array of the object type and I can store the multiple values in that. So maybe the first value I want to store inside this is 123. Maybe another value that I want to store inside this is, let's say, 3.14. The another value that I might want to store inside this could be, let's say, false. And another value that I want to store inside this is a string. If you want, you may store another value inside that is date time dot now. Please note that date time itself is a read-only structure. So here we have total 5 elements. This is nothing but my element at index 0, which is right now integer, element at index 1, which is double, element at index 2, which is boolean, element at this particular index is a string, and the element at the last index is given as date time. If you want to access these elements once again, you can access each object in the array and you can print them back. This is absolutely possible. This can be very well implemented. However, if you want to access a particular member, then you have to typecast it back to the respective type. You must have noted that in this particular case, the first 3 values and the last value, these are typical value types. When we are storing these value types inside the object array, we are doing boxing for them. And while accessing those elements back, then we will need to do explicit cast and unbox them. This will be a performance issue. Anyway, this is possible feature. Now that you have got enough idea about 1D array, we can talk about our one pending topic. I guess I was talking about the function arguments. And I was trying to tell you that we can have a function with the variable number of arguments. Yes, that is possible. Let me show you a quick demo of it. What exactly I mean by function with the variable number of argument. Suppose that I want to write a function called as an add-all. And in add-all function, I might want to pass only two arguments and I'm expecting some result out of that, which I can print later. res1 is equal to res1. I might want to pass maybe four arguments in this. And in that particular case, I want to print this. Or in general, maybe I want to pass n number of arguments to this, where I do not want to define this well in advance. It may have any number of arguments, and whatever number of arguments that we have, I just want to get the result from this. In this particular case, such kind of function will be considered as function with variable number of arguments or variable argument function. How we can implement this function? Well, such kind of function can be implemented as add-all using a params keyword. In params keyword, we can create one array of arguments. Now, whatever arguments we are passing, let it be 2 arguments, let it be 4 arguments, let it be 8 arguments, all of them will be packed in the array, and that array will be passed over here. Now we can quickly write our logic. In our logic, I can make sum is equal to 0, and then for each integer number in the array, I want to say sum is equal to sum plus number, and then I can return the sum. Here you can expect the results like this. This should be 3, this will be 10, and this one you can do the addition and you can check that this addition, even I don't know. Let me run it and quickly check. Yes, that addition 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 will be 36. Great. And this is how you can write the function with variable number of arguments. You can check console.writeLine was one of such function which can take any number of arguments from you. Now that you have understood the 1D array, you've seen the application of the 1D array, let us go on to the concept called the 2D array. Let me tell you that two-dimensional array is one of the specialized concept in C#, which I have not seen in the other programming languages like C, C++, and Java. Over here, the two-dimensional array is declared with a special syntax. You can note a comma over here. Let me call it as a mat, and that mat is equal to, let's say, new integer, and I want to make array of 3 by 3. When I say 3 by 3, it is about 3 rows and 3 columns, where let's say my first row is having 3 columns, 11, 22, and 33. My second row has got next 3 columns, 44, 55, 66. And next row have got another, let's say 77, 88, 99. That's it. This is how I can declare the array, two-dimensional array in the C#. Can we print the number of rows or number of columns explicitly? Answer is yes. The number of rows, you can print it by using mat.getLength, and I want to get the 0th dimension, which is nothing but the rows, and currently we have 3 rows. On the similar way, I want to see my next dimension, the number of columns that I have. So number of columns that I have, let's say mat.getLength, maybe we have 1, and this is nothing but 3 columns. Let us run this and cross check. Yes, we have right now 3 rows and 3 columns. Please note that each row must have same number of columns in this case. If you at all wish to access all the elements of the array, how you can access? You can access the each element of the array by using mat of ij syntax. Mat of I comma j syntax, where I represent the row and j represent the column. Let me put it like this. The first loop for rows, and then we can have another loop for the column, and then we can access the elements one by one I of j. Let me use tab after printing each element, and after my each line is completed, I can use one empty new line, console.writeLine, and maybe new line, or just for making it more readable, I will put it /n explicitly. Let me run this. Yes, you see perfectly matrix kind of feeling over here. That is wonderful. The 2D array is a special concept. However, we have another variation of the 2D array which is more flexible, and that next variation is referred as jagged arrays. So let me go ahead and create something called as jagged arrays. So what is jagged array? Jagged array is basically array of arrays. How do you write array of arrays? Something like this. So I can use mat is equal to new int 3 0, where I'm saying that this is array of array with 3 elements. Means this particular mat will have 3 arrays inside it. And how we can initialize each of that array? Let's say mat 0 is equal to my first array. And in that first array, I can initialize the value, let's say 1, 2, 3, 4. There are 4 elements. Maybe I want to write the next one where I want to keep only 2 elements. Now, it is not compulsion that each row should have the same number of columns. And then we have mat of 2 is equal to new int, and maybe I want to use 7, 8, 9. This is possible. How you are going to access the elements one by one? We can access the element by using mat of I. Mat of I will give me the access of the row, that is 1D array inside this mat array, and from that 1D array I can access the jth element. So we can write a loop something like this. Integer I is equal to 0, I is less than mat.length. Over here the length is 3. Total 3 1D arrays in this. Now in this loop, let me use for j is equal to 0 and j is less than mat of I, which itself is an array. Let me check the length of that, j++. And then we can access the elements over there, mat of I, and in that particular 1D array, jth element. Let me print a tab after that. After one row is printed, let me use console.write, and I will use 1/n explicitly. Let me run this, and you see the output. The first row is having 4, the second row is having 2, and the next row is having only 3 elements. You can see it diagrammatically over here. In this diagram, you can take a look at the mat is going to point to one array of 3 elements. And in that, each element is an array of integer. The first one is an array of 4 integer. The second one is an array of 2 integer. And the third one is array of 3 integers. This is how you can declare 1D array, 2D array, or jagged arrays in the C#. I hope you find this session very helpful. See you in the next session. Bye-bye.